Okay, another problem from 10.2. This is number 43. And it says a particle moves in the plane so that x equals cosine of pi t over 6 and y equals 3 sine of pi t over 6. So you have the position vector. This is your position right here. Find the speed, the acceleration, eliminate the parameter, find an equation x and y that defines the curve in which the point moves. So let's do A first. And we want to find the speed, so we're going to have to take the speed will be this is the speed. Remember, it's just the absolute value of the velocity vector, the magnitude of the velocity vector, so we got to find the velocity vector. So this is my position, so the velocity vector will be the derivative of the position vector. And the derivative of phi cosine of pi t is just, derivative of cosine is negative sine pi t, and then we've got the derivative of this is just going to be pi over 6 times phi. And the derivative of this 3 sine pi t, well, we've got 3. And the derivative of, it's going to be the cosine, and the derivative of pi over 6t is just pi over 6. So 3 times pi over 6 is just pi over 2, so that's what you've got. Okay? All right. Okay, hope that makes sense. So then we've got the speed equals just the absolute value of that vector, so we take the square root of each of these components squared. So negative 5 pi sine pi over 6t squared, and this is the y component, pi over 2 cosine of pi over 6t squared. So just this square root of the horizontal component of the velocity squared plus the vertical component of the velocity squared. All right? Now we want to find the speed at t equals 2, so that's nice. So we just substitute 2 in here. So this is going to be, everything's going to be the same except where I see a t, I put a 2. So 2 goes into 6 3 times. 2 goes into 6 3 times, so it becomes this situation here. And then I just kind of work these out by hand. That's okay. So 2 over 6 is 3. 2 over 6 is 3. And the sine of pi over 3 is the square root of 3 over 2. The cosine of pi over 3 is 1/2. And, gosh, I worked all this out, didn't I? Okay, and that's just going to be, well, we had to square everything, so we squared it. So we got 25 over 36 pi squared, and that's just going to be 3 over 4. Plus, and we square this out, get pi squared over 16. Because the cosine of pi over 3 is 1/2, so that's nice. And then what do we got? Well, we can simplify a little bit. 3 goes into, well, I didn't simplify that, I should have, but we multiply this. 3 goes into 36 12 times. 4 times 12 is 48, and 4 doesn't go to 25. Oh, I'm sorry, I did this over here, excuse me. Follow my work. And so 3 goes into there 12 times, and 12 times 4 is 48. And 3 goes into 48 16 times, this is what we had. So we put these all over a common denominator of 48. And we end up with 25 pi squared plus 3 pi squared is 28 pi squared over 48. Square root of pi squared is pi, so we have this, and then we finally simplified it out. So if we want to leave in terms of pi, we would get this. So there's some arithmetic. I guess I was in an arithmetic mood. So there you go. You can use the calculator anyway, so you could have started calculating it up here. But it's kind of fun to do the arithmetic. All right, so that was A. Now what was B? B, we want to find the velocity vector. Well, that's not too bad. We just take the derivative of, we want to find the acceleration vector, B. I find the acceleration vector t equals 2. So we just take the derivative of the velocity vector and put 2 in. So this was the velocity vector here, so we just take the derivative of that. And the derivative of the sine is the cosine, but we have to chain rule, so we have to multiply this by pi over 6. That's going to give me 5 pi squared over 36. And the derivative of the cosine would be negative the sine, so I got a negative sine. I've got this pi over 6. I have to multiply this by pi over 6. I get pi squared over 12. And then we just substitute t equals 2. We want to find the acceleration vector at t equals 2, so just put 2 in here. So again, 2 goes into 6 3 times. 2 goes into 6 3 times, so we've got this critter here. And the cosine of pi over 3 is 1/2. And the sine of pi over 3 is the square root of 3 over 2. And negative, and nothing here, 5. 36 times 5 pi squared, 36 times 2 is 72. And over here, negative, nothing simplifies there, so pi squared, square root of 3 over 24. So there's your acceleration vector at t equals 2. So there's a bit of arithmetic there, but nothing crazy. Letter C. Eliminate the parameter and find an equation in x and y that defines the curve in which the point moves. Well, we try to kind of work out, we try to sometimes get the Pythagorean identity when we have both these. So this is x. Go back and look at the very beginning. This was x and this was y. So if I square those, I get x squared equals this, y squared equals y squared. And if I square these out, I get 25 cosine squared pi over 6t, and 9 sine squared pi over 6t. And what we do is we add, if this x squared equals this and y squared equals this, okay, x squared, then we can divide by 25 and divide by 9. So x squared over 25 equals the cosine squared of pi over 6t. And then y squared over 9 equals the sine squared of pi over 6t. Now notice that these are the same. So we've got the cosine squared of something and the sine squared of something. So remember from your Pythagorean identities, those add up to be 1. So we just add the left side of these equations. And that would equal the sum. The sum of the left side of the equations equals the sum of the right side of the equations. So x squared over 25, okay, plus y squared over 9 equals this. But this is just the cosine squared of something plus the sine of something, that equals 1. So this is what we have. And what do we call that? That's an ellipse. Okay, I think we should see that. And if we wanted to graph it, you could graph it real fast. And it's not too hard to graph because there's no shift on this thing. And then when x is 0, this is y, this is x. So when x is 0, this drops out, and y equals plus or minus 3. And when y is 0 on the x-axis, x squared equals 25, so x equals plus or minus 5. So it looks something like this. So it's an ellipse, something like that. Sorry, it's not really symmetrical. It should be symmetrical. There's something like this. There, something in that form. All right, and then what we can do is we can put it in our calculator and just graph it. Now we know that that's easy. We can graph that by hand. Let's go put the original equation in and see what we get here, just to verify it. Oh, shoot. Y equals, and then what we have here, 5 cosine. That's going to be pi t over 6. And the other one was 3 sine. And let's see, what should our window be? Go back to our window. And I don't know how long it's going to, what the t is going to be. Now let's take t equals 6. And let's go x minimum, we know it's going to be 5, so we're going to go negative 6 to 6. And y we can go from negative 4 to 4. Let's graph and see what we got. There we go. And there's your ellipse, you see. Oops. 6 won't do it. You're only going to get half of it, so go back to your window and change your t max to 12. Looks like that's going to give us the whole thing. And you see that we got an ellipse there. Okay. Does that make sense? That's pretty cool. Hope that helps.